Hello everyone. So we're going to start looking at number theory. Number theory, right? And there's a lot in here, but for me, I just like to remember it as the math while we work with remainders, because that's the most thing you're going to be working with. You're going to be working with the modulus operator. In programming in Java, it's this symbol over here. So a few things to remember. First of all, is congruence. If we have A is congruent to B mod n, what does this mean? Well, what this basically means is, um, so these two, when divided by n, they leave the remainder. So what we can say is that if a number, if we divide n, right, so a can be expressed as n by some integer, let's say s, plus a remainder, because you know it leaves a remainder. Then now we also have b. B here is can also be expressed as n by some other integer t, because we can't say n goes into a and b the same number of times because we don't know what a and b are. So use s and t. Then plus r. The reason we use r and r here is because we know that these two leave the same remainder. Now to express this with actual numbers, it's more like saying 9 is congruent to 14 mod n mod 5, right? We know that 9 can be expressed as 5 times 1 plus 4, right? Then we also know that 14 can be expressed as 5 times 2 plus 4, like that. See, this is our A, so let's say imagine this is our A, this is our B. So they have that there, and then they do 5 goes into them, so our n there. It goes into them different times, but our remainder is the same. Hence we say they are congruent to each other. Then now, from this, what we can say is, what we can derive is n. So n divides a minus b. So this is divisibility, right? What this basically means is that n divides a minus b without leaving any remainder. And we can quickly prove this by simply saying a minus b, right? A minus b. Now, what is a? A is ns plus r, right? Minus, what is b? B there we know it is nt plus r. Expanding this we get ns plus r minus nt plus minus r there, minus r, like that, which this kills that. Then we get ns minus nt. We can factor out the n getting s minus t there, which then just gives us nv, for instance. Simply we know that, okay, this is true. And then just to go back to these guys, it's more like saying um it's more like saying, what's this? It's more like saying, let me just use 14 minus 9 there, right? I can still use the other one, just be negative, but 14 minus 9, this is equal to 5, which is divisible by that. We also have 9 minus 14, which is just negative, negative 5, which is just 5 times negative 1, which is in this form. This is also in the form 5 times 1, which is also in this form. So basically, if you have this, conversely, you also have this. So we're going to be using these two principles to prove a lot in this chapter. So yeah, this is just a basic overview of what we're going to be doing. There is still a lot that we're going to learn about. For instance, the GCD. We're going to use this a lot, and then after we're comfortable with the GCD, we can start looking at encryption. We're going to start looking at encryption as well. And encryption, there are two algorithms that we're going to learn about as well. I'm also going to show you a simple Java program that I wrote once that we're going to be using for encryption. It's not necessary, but it's just something I did for practice, and just so we can demonstrate the things as they are happening instead of actually just doing the math all the time. But yeah, it's just a brief overview and introduction to this chapter. Next video, I'm just going to get straight into the questions, because the best way to learn is by solving. Yeah, bye.